question asks, 5-card poker is played with a standard deck of 52 cards. The cards are sufficiently shuffled and 5 cards are dealt to 2 or more players. It is typical to call the 5 cards dealt to a particular player a hand. Hands are ranked in the following order, as seen on the board, and these categories are taken to be pairwise mutually exclusive. So the question asks that we have to verify the rankings in the above list on the board, and we have to see if it's justified by calculating the total number of hands possible in each case. So just for reference, the total possible is 2,598,960. So the first one we're doing is the straight flush, and there are 10 possible low cards. So out of the 10, you're choosing 1. And then for the suit, you can only have 1 suit, so it's 4 choose 1. And basically, a straight flush is where the 5 cards are a consecutive sequence and all the cards are from the same suit. So for that, we get 40, and the probability is 1.5 times 10 to the negative 5th. For 4 of a kind, we're basically just choosing 4 of the same rank, and then they can all be different, or they all have to be different suits, and then one of them can be anything. So from the 13 ranks, we're choosing 1, and then there's 4 suits, so 4 choose 4. And then for the last card, it can be anything, so 12 choose 1, and then that can be any suit, so 4 choose 1. So that's 624 possible hands, and the probability is 2.4 times 10 to the negative 4. So for the full house, it's 1 pair with equal face value and 1 triple with equal face value. So basically from the 13 ranks again, we're choosing 1, and then since we're only choosing 3, you're only choosing 3 of the suits, so it's 4 choose 3. And then for the next pair, it's 12 choose 1, and since there's only 2, you're choosing 4 choose 2 for the suits. And that's 3,744 possible hands, which is 0.0014 probability that this will occur. For the flush, it's a hand that's all just 1 suit. So from the 13 ranks, you're choosing 5, and from the 4 suits, you're choosing 1. But also, we have to remove the straight flush, since that's a special case. So that is 5,108 possible hands with a probability of 0.002. And for the straight, it's 10 low cards again, choose 1, and then all of them can be different suits, so 4 choose 1 to the 5th. And then again, we're removing the straight flush since it's a special case. So there's 10,200 possible hands, and the probability is 0.0039. For 3 of a kind, basically 3 cards of equal face value, and the 2 cards can be anything. So for the 3 of a kind part, it's 13 ranks, choose 1, and then those 3 have to be 3 different suits, so 4 choose 3. And then for the other 2 cards, they could be anything, so 12 choose 2, and each of those can be any suits, so it's 4 choose 1 times 4 choose 1. And that's 54,912 possible hands, with a probability of 0.0211. For 2 pair, it's basically in the title, you get 2 of 2 different pairs. So from the 13 ranks, you're choosing 2, and for each pair, it's 2 different suits, so it's 4 choose 2 times 4 choose 2. And then you have 1 card that can be anything, so it's 11 choose 1. And then for that card, you're choosing the suit, so 4 choose 1. So that's a total of 123,552 possible hands, which is a probability of 0.0475. And for the 1 pair, it's just in the name 1 pair. So from the 13 ranks, you're choosing 1. And since a pair, you have to choose 2 suits, so 4 choose 2. And the remaining 3 cards can be anything, so 12 choose 3 from the remaining. And then each card can be a different suit, so 4 choose 1 to the 3rd power, which is 1,098,240 possible hands, which is a 0.4226 probability of this happening. And for nothing, it's just nothing from before this, so it's 13 choose 5, and each of those can be a different suit, so 4 choose 1 to the 5th, which is equal to 1,317,888, which is a probability of 0.5071. So basically, this rank is justified since the number of hands increases as we go through the board.